All right. Well, hope everybody's doing okay today. We are finally going to get the opportunity to start trig. It's going to be the largest concept, that we talk about in the classes. It's going to have so many things for us to bring up, but we're going to start today talking about a lot of the vocabulary, what we do with certain things, and then at the end we'll go ahead and take our quiz on inverses. So we'll go ahead and make sure to stop, probably about 20 after, give you guys a good 15 minutes at least. Don't forget a couple things tomorrow. The waivers are due if you are needing one, possibly for this class or another weighted or upper level, to Marcia Edwards by 10 a.m. That's Mr. Young's secretary. We already had the tornado drill. How'd that go? It was pointless. Okay. There was a little bit of confusion downstairs, but that's why we practice, so in case of a real emergency, we get that taken care of. Talked about the quiz, and then a week from Monday on the 8th is when we're going to be looking to have our first exam over all of our material here. Okay, good. Well, let's go ahead and get started. Angles and their measures. Engineers in the ancient world discovered ratios within right triangles. As they learned fundamental engineering skills, the secrets and patterns necessary to understanding circles and spheres helped in the development of trigonometry. Our chapter begins the journey into trigonometry with an introduction into angles and their measures. Like I said, a lot of vocabulary, more than anything, is coming up today. So angle characteristics. Okay, this is the core idea. An angle is determined by rotating a ray about its endpoint. So we remember from geometry that a ray is just a line segment that goes forever in one direction. Now, the blank is the endpoint of the ray. Well, that would be the vertex. All right. The vertex is the endpoint of the ray. The initial side is the starting position, okay, before you begin rotating, whether clockwise or counterclockwise. And then the terminal side is the position after the rotation. This is where it stops. The terminal side is the position after the rotation. So good. See what else we got here. Standard position angles. All right, well, angles that are in standard position are placed on a coordinate plane with the vertex at the origin and the initial side on the positive x-axis, just like we have here in the diagram. So from the positive x-axis, okay, we're either going to go ahead and rotate counterclockwise, or we're going to go ahead and rotate clockwise. And that's going to give me two different types of angles here. Can anybody tell me what type of angles are determined by a counterclockwise rotation? This starts with a P. Okay, give you a hint. It's not negative. Positive. There we go. Positive angles. Okay, so positive angles. So if I'm starting here in standard position, that means the positive x-axis, and I have a positive angle, well, then I'm just going to go ahead and rotate and stop whatever angle measure I happen to be provided. And we're also going to go ahead and start looking at radians as well, but we won't get to those until tomorrow. So if a positive angle means I'm going to rotate counterclockwise, then what angles are determined by a clockwise rotation? Negative. There you go. So negative. And we're not saying that the angle itself is negative. The negative simply tells me what direction to go ahead and rotate. Okay? So let's talk about another idea now called coterminal angles. Two angles in standard position that have the same terminal side are called coterminal angles. So when you're thinking about this, you're looking for two angles that have different measures, but they have the same terminal side. That means they both stop at the exact same location, starting from standard position, the positive x-axis. We can find an angle that is coterminal to a given angle by adding or subtracting one revolution. Okay, so in degrees, how many is in one revolution? 360, right? Okay. So if we start here on the positive x-axis, that would be 0 degrees. And let's say I rotate counterclockwise. Well, there's 4 quadrants we have here. So how many degrees in one quadrant? 90. All right, so I'm going to have 90 degrees here. Half of 360? 180. What about 3/4? 90, 90, 90. 270. There we go. Until I get back around to 360 degrees. Okay. So basically, you're just going to be adding and subtracting multiples of 360. That's all you're going to be doing, right? So any given angle has an infinite number of coterminal angles because we can continue to rotate in whatever direction we want. Okay, so for example, we've got beta is equal to 36 degrees. All right, so what quadrant would that be in? Definitely the first one, okay? And remember, it goes counterclockwise, 1, 2, 3, 4. So let's say that this is 36 degrees. We always start on the positive x-axis. Positive, we rotate up, which is counterclockwise. Negative, we rotate down, okay, which is going to be clockwise. So here's the thing. What I'm going to be asking you to do most times is looking for one positive and one negative. Okay, so let's go one positive. Let's say I start in standard position. Well, if I just go ahead and rotate until I get to that terminal side, well, right now I'm at 36, right? And remember, I said to find those coterminal angles, you're just going to be adding and subtracting one revolution, 360. So if I go all the way back around until I hit it again, that would be what I'm referring to as coterminal. So what is 36 plus 360? 396, and you'll notice that's one of the coterminal angles they have listed here. Okay. Now, if I wanted to go in the opposite direction, so that right there, that was 36 plus 360, which gave me the 396. Now let me do one in the opposite direction. Let's find one negative. So I'm going to start here, and I'm going to rotate all the way around until I hit that same terminal side. So for this one, I want to subtract the 360. So that's negative what? 324. Again, another one that they have listed right here. Okay, but you remember I said there was an infinite number of coterminal angles? Okay, so let me show you this again. Let me kind of take off these right here. All right, let me go ahead and show you 360, or excuse me, 36 degrees. There's my terminal side right there. Well, let's say I go ahead and I'm looking for the positive, right? So I rotate until I hit the terminal, and then I've got to go one more revolution, an extra 360. But there's nothing saying that I can't continue to rotate. Okay, I already did one revolution, so that's plus 360. I could go for a second revolution, which is plus 2 times 360. I could go for a third rotation, which would be plus 3 times 360. That's why I said earlier it's just multiples of 360. And I can continue to do that as many times as I want. Could I also rotate infinitely many times clockwise? Yeah, so I could subtract 360, subtract 2 times 360, and just keep going. But typically, I'm just going to ask you for the one positive and one negative. Okay, so let's try an example. Let's try another one. Let's see what you guys think. Example 1 says theta is equal to 220 degrees. So I have my 0. I've got 90, 180, 270, and then all the way back around to 360. Okay, so what quadrant would 220 be in? It'd definitely be in third. Okay, because 220 is going to be between 180 and 270. So let's say the angle would stop maybe right about here. Now, I'm probably not drawing that very accurately, but that's okay. So this is 220 degrees. All right. Now, all I'm wanting is one positive and one negative coterminal angle. So all I really have to do is take 220 and do two things. I'm going to add 360, and then I'm going to take 220 and do what? Subtract 360. And let's see what this looks like visually. So if I start here, what do we call this again when I start on the positive x? That's standard position. Okay. Where you start to rotate from, whether clockwise, counterclockwise, that's going to be standard position. So let's say I start here and I'm looking for one positive, right? Okay. Well, again, if I go ahead and stop there, all I've gone to is 220 degrees. So I've got to go all the way around again one revolution to get back to the same location, the same terminal side. That's why the first time we're taking 220 plus 360. So in red here, what is that? What is 220 plus 360? Okay, that's going to be 580. So the one in red's 580 degrees. Okay. Now let's do the other one in green. Okay. So, or it is a different color so you can tell the difference. So again, I'm going to start here in standard position, and I'm going to rotate clockwise until I get there. Okay. So this is where the other idea comes in, 220 minus 360. Well, somebody help me out. What's that? Oh, but what kind of 140? Negative. It would have to be negative because that tells me the direction I want to rotate, right? So negative 240 degrees. Oh, I'm sorry, 140, I'm sorry. Just see if you're paying attention, and obviously you were. Okay, negative 140. Okay, so that's what we're talking about when we say coterminal angles. Okay. Any questions on coterminal angles? Okay. What do we call the side of the angle that rotates? Okay, where it stops, that's the terminal. Okay. Where it begins is the initial. If it starts on the positive x-axis, we say it's in what? Standard position. Okay. So let me go ahead and give you another one of these. All right. Let's say you've got angle theta is equal to 130 degrees. So I've got 0, 90, 180, 270, and then all the way back around to 360. Okay. And I want you to find me one positive and one negative angle that's coterminal with 130. All right, so first off, what quadrant would he be in? Second quadrant. Okay, so let's say 130. It's going to look maybe like this. 130 degrees. Okay, so I'm going to go one positive, starting in standard position. If I rotate around, see, there's just 130. So I'm going to add 360. I'm going to add one more revolution. So Rhett, help me out with that. I need 130 plus 360. 480? We're close. 490. There we go. So that's 490 degrees. Okay. Is everybody okay how I got that? And then if I continue to add 360, I'm just going to get more and more coterminal angles over and over again. Okay, so now let's go ahead and do the other one. Again, if I start on the positive x-axis, that's what? That's standard position. So now I'm going to rotate clockwise until I have the same terminal side. We stop in the exact same place. So this is going to represent 130 minus 360. Okay, negative 230. Would you guys agree? Okay. Any questions on coterminal? Pretty easy? Okay. All right. The one thing I don't want to do in this lesson is definitely try to trig you. You know, it's a stretch, but I'll stand by it. Trig. You'll laugh later. Okay. Always later. Okay. All right, next up. Okay, reference angles and methods to measure angles. Okay, so reference angles and coterminal angles are two completely different ideas. Given an angle in standard position, its reference angle is the acute angle formed by the terminal side of the given angle and the x-axis. And really what I should say here is the closest x-axis, whether that be the negative or the positive portion of him. Whatever the closest x-axis is, that's where you create the angle. So let's say this one here at the left, it says the angle is 210 degrees. Okay, we want to know what the reference angle is. Okay, well, by definition, okay, the angle that we're looking for, it's created using the terminal side and the closest x-axis. Okay, so in this case, it would be the negative x-axis, right? All right. Well, what's half a revolution? 180. So what I'm looking for here is just the difference between 210 and 180. That would give me 30. So I know this reference angle would have to be 30 degrees. That's what the reference angle is. The angle created between the terminal and the x-axis. Okay, let's try a few more of these. 2A, 150 degrees. Okay, Andrea, what quadrant would that be in? Second quadrant, okay. So I'm going to rotate over. Let's say the terminal side's right here. So that represents 150 degrees. Okay. So again, I'm looking for the angle created using the terminal side and the x-axis, again, which is this right here. So Brandon, what is it? Again, this angle is going to be 30, yes. The reference angle is once again 30. Okay. Hey, Brandon. Oh, how did I know this one right here? Oh, you're just thinking about your measurements. Because remember we went through just a second ago. Remember, we start here at 0 degrees. Okay, straight up is 90, half is 180, 3/4 is 270, and then I get all the way back around to 360. So if I'm looking for a 150 degree angle, I know that I'm going to stop somewhere between 90 and 180. Is everybody okay with that? Okay. All right. So I want you to help me out on the next one, Brandon. Which quadrant, 1, 2, 3, or 4, would have 315 degrees? It's going to be the fourth quadrant, yeah, because it's between 270 and 360. Good. So let's say I go ahead and draw them to look like this. So we rotate all the way around. So this is 315 degrees. Okay. Now this time the closest x-axis is the positive. So between the positive and the terminal. So this time I want to take the difference of 360 and 315. What would that be? Oh, say it again, Brandon. 45. So my reference angle is 45 degrees. And remember, it's always positive. The reference angle is always going to be positive. Is anybody having a hard time with this idea? No? Okay. Well, let's try 2C. Now, what's different about this one? Now, it's negative, so I'm not going to rotate counterclockwise. I'm going to rotate clockwise. Now, if you're rotating clockwise, these values are going to kind of switch up. This would be negative 90, negative 180, negative 270, until I get all the way back around to negative 360. You're just reversing those. Because again, we're not saying that the angle itself is negative, it's just the direction you rotate. Okay? So if I want to go negative 120 degrees, what quadrant would that put me in? That put me in quadrant 3. Because negative 120 is between negative 90 and negative 180. So let's say it's right here. Negative 120 degrees. So again, I'm looking for the angle created using the terminal side and the closest x-axis. So don't worry about the fact that it's negative. Okay. This guy is symmetrical, and you're going to find that as we go through. So I rotated 120 degrees. How far am I away from 180? Oh, remember, I'm just sketching these. I'm not going for the accuracy. Oh, yeah, yeah. Now, I want to make sure I understand what your question is. Use which one we want. Uh-huh. Oh, yes, but it's always the x-axis. You always put the terminal and the x-axis to make that angle. Always, always the x-axis. Okay, so I see what you're saying, yes. But in this case, yeah, you'd only have to go another 60 degrees, and you'd be to the x-axis. So there's your reference angle. Okay, good. Okay, now I understand what he was asking. Okay, let's try this last one. 140 degrees. Adolfo, what quadrant would it be in? 1, 2, 3, or 4? 2. Okay. Because again, we have 90, we got 180, we got 270, and then 360 all the way around. So let's say, 140 looks like this. 140 degrees. Okay, so the reference angle is created using the terminal side and the closest x-axis. So how much further do I have to go from 140 to get to 180? 40, that's it. That's what a reference angle is. Okay. Now, let me go ahead and give you a couple of extra just so you kind of get the idea. Because there are some ones that could be a little strange looking. Let's say I gave you, and let's use the previous one we had, 36 degrees. So what would the reference angle be? It would be 36. Remember, think about what the definition says. Okay, we're looking for the angle created using the terminal side and the closest x-axis. So in quadrant 1, an angle is its own reference angle. Is everybody okay with that? Okay. But now, what if I did this? Let's say I rotated negative 75 degrees. So I stopped in quadrant 4. It would be 75. Again, by definition, I want the angle created using the terminal side and the x-axis. But remember, I said the reference angles are always what? They're always positive. So 75 degrees. Okay. So is anybody having trouble with coterminal or reference angles? You want another example like this one, where it's a negative rotation? Yeah, sure. Let's see. What do you think would be a good one, man? Negative what? Negative 295. Okay. So negative 90, negative 180, negative 270. Then we get all the way back around to negative 360, and of course we start at 0 degrees. So she's giving me an angle of negative 295 degrees. All right, so what quadrant is this going to put me in? I heard the second one. I've heard the first. Okay, it's going to be in the first. Okay. All right, so Brandon, we're good? Okay. Because see, the 295 is definitely bigger than the 270. Again, the negative just tells you direction. So it's between 270 and 360, so maybe something like this. So right here would be a negative 295 degrees. So what I'm looking for is this guy right here. So how much further would it be to go from this 295 to finish the revolution? 65 degrees. There you go. Okay. Brandon, is this good? Okay. Any other questions? How we doing? Hey.
If we do the negative and the reference angle, that won't be negative.
If we do yes, the reference angle is always positive.
It's
always positive. That's exactly right. Good, 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 good. Okay, now I think this is pretty much the last idea we're going to be able to get to today. This is about where the other classes were getting. I want to go ahead and introduce you to an idea called degrees, minutes, seconds, DMS. Okay, so what we want to be able to do is convert between a decimal degree and degrees, minutes, seconds, but also go back at the same time. So I've got these conversions here. So 360 degrees is one full revolution, like we talked about. Now, 1 degree is equal to 60 minutes. This little tick mark right here, when you have 1 dash, okay, that's referring to minutes. So if I have 2 dashes, that's what? That's seconds, yeah. So 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. That makes sense. You know, we already knew that. And now 1 degree is going to equal 3,600 seconds. Now, if you're interested, I'm not going to really push for you guys to know these by hand. Okay, they are up here if you wanted to go ahead and kind of look at them. Maybe we can talk about it tomorrow as well. But I want to go ahead and just show you how to convert these using the technology. Because in the grand scheme of things, it's nothing that is super important you need to know by hand. Genevieve? Like I said, if you want to. Otherwise, we're just going to go with the technology. Okay, so let's say I have this right here. 36 degrees, 25 minutes, 18 seconds. And I want to go ahead and convert it to a decimal degrees. Okay, so the conversion itself is really easy. You just have to know the keystrokes. All right. So I'm going to come on over here to my calculator. All right, so I'm first going to go ahead and type in the 36 for the degrees. Now, if you hit Control and you come on over here to your catalog, the open book one, okay, you'll notice that in the top right, that's where your degrees are at. Okay, so I type in 36 degrees. Then I believe it was 25. Okay. Now I'm going to go to the exact same place. I'm going to go Control, Catalog. And you'll notice right here in the second row, there's that tick mark for minutes. Okay. And then the last one is 18. And then we're just going to have to go ahead and do this twice. So I'm going to click once and twice for the seconds. So this is exactly what's on my paper, right? 36 degrees, 25 minutes, 18 seconds. Well, when I push enter, it's going to give me the fractional equivalent, but how do I convert that to a decimal? Yeah, I'm going to hit Control, Enter. 36.4217. If you take a look, this is exactly what we have here. Okay. Now, let me ask this question. Is there anybody's calculator who is giving us something different? In fact, if it is something different, it's going to be like a 0.6 something. Okay. Here we go. Here's why your calculator is probably in radians. But what are we talking about? We're talking about degrees. You see right up here in the top right, mine says DEG. It's in degrees. And that's one thing that we do need to be able to make sure of, whether we're dealing with degrees or radians, that we can change that easily. So here's what you do. From your home screen, we'll just go to Settings, okay, Document Settings, and then the second tab right here. See, mine's in degrees. So you'll click it, okay. Like mine's already in degrees, but if you want to change it, of course. But now here's what you're going to want to do. Don't click OK, click Make Default. Because otherwise, after you use one operation, it'll actually convert right back to what it was previously. Okay. All right, how are we doing on time? 12:20? Okay, so I'll go ahead and stop there. Just remind me for tomorrow, I showed you 3A, but we need to go ahead and start with 3B. Okay? All right, good. So